When we talk about Rutherford's contributions to the atomic structure, he figures out that it's mostly empty space, right? Most of this is actually empty and nothing is there. And the centermost part of the atom is positive. So when we used to depict Rutherford's model, we'd actually draw it as either this big, mostly empty ball with the electrons somewhere on the periphery, on the outside, or we draw this kind of like Jimmy Neutron sort of image where you had the positives in the middle, and then it kind of looks a little more official and more, scientific. But it's actually wrong, okay? And it's basically Niels Bohr that comes up and he says what? What does he talk about? What's his big claim? The orbits, right? The electron shells are orbits. Now, when we draw a Bohr-Rutherford model of an atom, we didn't even know that neutrons existed, and we're not talking about neutrons. We're talking about the atomic number of something. We know what atomic number is, correct? It's the number in each of those boxes. What does the atomic number represent?
The number of electrons and then also the number of protons.
So it represents the number of protons, because protons, Rutherford was only talking about protons, right? So if I draw, let's say, an atom of beryllium, okay, what is beryllium's atomic number? 4, thank you. 4 plus, okay, that's how many, and actually I'm going to do this in a different color. 4 is how many positives or protons an atom of beryllium has. And that is found in the nucleus. So I draw a circle around it, okay? Now, how many electrons will beryllium have? It will have 4. So according to Bohr, what was his big contribution? The shells. How many electrons go on that first shell?
2.
How do you know there's only 2? Because I told you. Because how many atoms are in the first period?
2.
Only 2, right? Patterns in the periodic table. Now, how many am I missing here? I am missing 2 more. So I'm going to draw that other shell, and I'm going to only put, bless you, 2 more. So this is a Bohr-Rutherford depiction of an atom of beryllium. Nowhere in the image do you actually write the symbol of the element. Okay? It's understood that the symbol, you can figure out what this is based on what? What gives away what this element is? The atomic number. The atomic number is a characteristic property of each individual atom. And if we remember from grade 7, characteristic properties are properties that only one thing has. So if I say the girl had blonde hair, well, that doesn't narrow it down, right? Because there's several girls in this class that have blonde hair, okay? Sure, it narrows it to some, but it's not a unique characteristic. But if I say she was wearing a dress with bones on it, in the room there's only one person right now that's got a dress on with skeletons on it. Therefore, that is a characteristic descriptor of just me, okay? When we talk about atoms, a characteristic descriptor of atoms is their atomic number, because no 2 atoms have the same atomic number, right? So if I draw out an atom here, you basically can identify what the atom is if you know what my atomic number is going to be. So let's look at the actual atom that was drawn up top on the board, and let's see. Can you identify what element this is? Open your eyes and have a look. Okay? Yes? It's titanium. How did you know that? because I know the periodic. No, but what is the hint here? What gives it away? Yes.
If you look at the center with the protons, you could just, that's the atomic numbers you just.
Who bloody well cares what is happening out here? This took me forever to draw and it's useless. Okay, I can well, it's not useless, it's important. But I can identify what a Bohr-Rutherford model looks like based on knowing its atomic number. Same thing is, if I ask you to draw me the Bohr-Rutherford model of, I don't know, sulfur, okay? You would look for sulfur on the periodic table, and you would look for what? No, that's titanium. Good try, though. You would look for sulfur.
16.
Yes, sulfur is 16. Sulfur is 16. So, if I want to draw an atom of sulfur, what has to go in the center?
16 plus.
16 plus. Okay, and then how many shells is this atom going to have? Sulfur is going to have 3. Why?
2, 8.
Because it's in what? It is in period 3. Therefore, it's in the third row. It's going to have 3 shells. 1, 2, 3. And this is where we go with the 2. The 8. Okay? Down here. And then how many left? What's my valence electrons in sulfur? 6? 6, because it's got row, so it's going to have 6 valence electrons. 1, 2, 3, 4, 5, 6. There is a Bohr-Rutherford representation of sulfur. The last thing, the last model that I want to talk to you about is something called the ball and stick atomic model. Okay, and you've often heard me refer to, or seen me draw atoms. This goes back to Dalton's idea of atoms, right? Where atoms are solid balls and they have different colors, represent different atoms, different sizes. And when we bond them together, we're linking them with a stick. So H2O, you're going to have your O in the center, and your H's are going to come off to the side. Okay? NaCl, if NaCl is written like this, how many NAs do I have?
1.
I have 1 here because there's no little subscript, right?
Just connect them.
So how many Cl's do I have?
1.
I've got 1. So here you would just draw Na bound to Cl. What happens if I have something like CaCl2? What would I do there? Who would go in the middle?
Ca.
The Ca would go in the middle. Ca, and then where would the Cl's go?
On the side.
1 on each side. Do you see that? Okay, a smaller ball here, Cl, smaller ball, Cl. And this implies CaCl2. There's your ball and stick. Okay? I'm not going to probably put any ball and stick on the test, but there will be Lewis notation and there will be Bohr-Rutherford on the test. Okay?